Yes, in today class, actually we are going to discuss about the topic on strain gauges. Strain gauge act like a transducer, resistive transducers. So in previous class, we had a discussion about resistive potentiometer. So in resistive potentiometer, which is also comes under the type of resistive transducer. So what is that strain gauges? The strain gauge and this class we are going to see about how the construction and the working principle, advantage, disadvantages as well as the application. So what is the meaning of strain gauge and what is the working principle of strain gauge? So the working principle of strain gauge, which is nothing but piezo-resistive effect. What does it mean, piezo? Piezo, actually the word which comes from the Greek and piezo, which is nothing but press. In previous discussion, we had the same like a piezo-resistive effect. We had a discussion on the topic piezoelectric effect. So you should know the difference between piezo-resistive as well as piezoelectric effect. So piezoelectric effect, which is like a piezoelectric transducer, in which when the pressure is applied, will get an output in terms of electrical voltage. That is what piezoelectric effect. So this piezoelectric effect, actually we had a discussion in the previous class and the topic was piezoelectric transducer. So we had a discussion on seismic transducer. So now we are going to see piezo-resistive effect. What does that mean? So piezo-resistive effect in the sense when a metal conductor is stretched or compressed, its resistance change. Just look at the diagram here. I have just given a metal conductor and the F, which is indicated as in force. So when a force is applied to this particular metal conductor, what will get? There will be a deformation. So when a force is applied, you will get a change and the term we used to call as in deformation. What is the meaning of deformation? That means there is a change in length as well as change in dia. So that is what I have given. The indication is L, then del L. That means the L is the indication of original length, del L, which is nothing but change in length, and the original dimension I have given capital D, and the change in dimension I have given, the indication is del D. So when a metal conductor is stretched or compressed, its resistance changes. That was the effect of piezo-resistive. That is what my strain gauge. So the strain gauge actually used for measuring a strain. So wherever you want to measure a strain or stress, then we can go for this strain gauge transducer. Not only that, your strain gauge will also act like an primary transducer as well as secondary transducers. So what does it mean? Suppose like you have some input device, that output will be given as an input of the second device. Then this will be your secondary. So here the strain gauges we are using for secondary transducers also. And how this is act like in secondary, whenever you are going to connect it with a device called the diaphragm type pressure gauge, or else if you are going for torque meter or accelerometer device for flow measurement, in those devices this strain gauges will act like a secondary transducer. So here your input is force and the output is in terms of change in length or change in dia, that is your resistive changes. So this is all based on the expression is capital R, which is equal to rho L divided by A. So what does that mean? Rho is nothing but change in resistivity, that is your material, what type of material you are going to use. Then L is nothing but change in, like your original length, there is a change in length, that will be indicated del L. A, which is nothing but your change, like area. So it's all depends on the dimension of a particular conductor. So that is how the working of your strain gauges. And moreover, when it comes for the strain gauge, there is one more thing, how we can derive using this particular expression, how we are going to analyze the del L as well as the delta D changes over in the strain gauge. You can just look at here. This is what your expression R, which is equal to rho L by A. So here with respect to stress, that means whenever it's going to get compressed or stretched, then there will be a change, right? So if it is I am just going to apply a force on that particular metal conductor, what will be the change? That is what I am going to analyze over here. So if there is a change in stress, so this particular expression R, which is equal to rho L by A, if there is a change, then it will be getting differentiated. So my equation is dr by ds, which is equal to rho by A into dou L by dou S minus rho L by A square into dou A by dou S plus L by A into dou P by dou S. How you can able to arrive this expression? It is the form of, you all know, U by V. What is U by V? That is U into V dash minus V into U dash. Okay. So based on this expression, that is based on this differential equation, I am just going to differentiate R, which is equal to rho L by A. So when you are differentiating the given equation, you will get this. That is, in terms of this one, I am just going to take first term is rho, then 1 by A, then L. So the first term is rho. If I am considering L, I am just differentiating. You will have rho by A into dou L by dou S. Then second term is 1 by A. So 1 by A means you will have differentiation. It is going to be 1 by A square, and the term is in the denominator. So it's going to be minus 1 by A square dou L by rho L by A square into dou A by dou S, then plus dou rho by dou S into L by A. So this is, I am just taking equation number 1. So the same equation I am just going to divide by R equal to rho L by A. So when you are going to divide, I will get the expression 1 by R dr by ds, which is equal to 1 by L into dou L by dou S minus 1 by A into dou A by dou S plus 1 by rho into dou P by dou S. So what does it mean, this del L by L, del A by A, del rho by rho? So these are all related to the dimensions. So we can call it as an unit change in length, then unit change in area, then unit change in resistivity. And you all know area formula, that is nothing but A, which is equal to pi by 4 into d square. So I am just going to differentiate this particular expression. So I will have dou A by dou S equal to 2 into pi by 4 into d of dou D by ds. So this dou D as well as D, both are similar, so no problem. So the same expression I am just going to use it, multiply with 1 by A into dA by ds. What will have, already you have the value of A, that is pi by 4 into d square, and dou A by dou S I am getting 2 into pi by 4 d into dou D by dou S. So I am just simplifying those things and I am just substituting those values. So we will have 2 by d into dou D by dou S. This is, I am just going to take it as an expression 2. So after substituting this 1 and 2 in the expression of my 3, So what I'll have 1 by r into dA by ds equal to 1 by L into dou L by dou S minus 2 by D into dou D by dou S plus 1 by rho into dou P by dou S. So this is what I am getting the expression. And you all know what is Poisson ratio. Poisson ratio, which is nothing but lateral strain by longitudinal strain. Lateral in the sense dimension, so dou D by D. Longitudinal, which is nothing but your length, that is rho L by L. So your Poisson ratio V, which is equal to dou D by D overall by dou L by L. This is what my Poisson ratio. So after this, from the expression, I am just going to find out what is my dou D by D. So I am getting minus B into dou L by L. So I am just substituting those value in the previous expression, that is my equation 3. So I am getting 1 by r into dr by ds, which is equal to 1 by L into dou L by dou S plus V into 2 by L dou L by dou S plus 1 by rho into dou P by dou S. So the dou S is common for all the terms, so I am just simply cancelling those. After this dr, it's a small variation, so I am just going to use the letter instead of this dou as well as d. I am just going to use this delta, so no issue at all. So del r by r, which is equal to del L by L plus 2 into V of del L by L plus del rho by rho. And what is Koch factor? So Koch factor, which is nothing but delta r by r divided by del L by L. This is what Koch factor. So from the Koch factor, I am just going to identify the value del L by L. That means this is, call it as in strain, that is change in length by original length. So I am just going to use the letter epsilon. So I am just replacing this del r by r. I am just going to have gf into del L by L. So finally del r by r, which is gf into E. So after substituting those terms in that particular expression, I will have 1 by 1 plus 2v plus del rho by rho divided by epsilon. So the first term del L by L, which is, if I am dividing this, I will get 1. So this is resistive due to change of length. Then second one is due to area. The third term is due to piezo-resistive effect. So when you are considering this piezo-resistive effect is very negligible amount. So you will have finally 1 plus 2v. So this particular expression, that is my equation 3, is going to divide by del L by L. So when the sixth equation, if I am dividing by delta r by r, I will have the expression Koch factor, which is equal to 1 plus 2v. This is my final expression, Koch factor, which is equal to 1 plus 2v, because the piezo-resistive effect is very, very negligible amount. So this is how, using this basic expression r equal to rho L by A, I am getting the Koch factor expression is 1 plus 2v. So this is how I am getting the expression. So while you are concentrating on this strain gauge, this strain is very, very important, because there is positive strain as well as negative strain we have. So positive strain means it is nothing but if the length is increased, positive strain. So positive strain in the sense, which is nothing but your length will get increased while its area of cross section, that is A, will get decreases. This is what positive strain. and moreover the Poisson ratio, that is your nu value, it is not same for all the metals, it is going to vary. So for metal the value is going to be 0 and 0.5, and moreover if you are going for nickel, the gauge factor value is minus 12.1, and for platinum the value is plus 4.8. Then for carbon the value is plus 20. In the same way, if you are going for nichrome, the value is plus 2. Then for manganese, the value is plus 0.47. So these are some of the gauge factor values of different metals. So based on the application, they can choose the metals. So wherever the positive values, these are all the strain gauge, that means positive strain values, and the negative one is negative strain values. So based on the metal, the gauge factor value is going to get vary. Accordingly, we can use our applications. The next one is about what are the different types of strain gauges generally we have. So there are so many different types of strain gauges. The first one is bonded strain gauge. The next one is unbonded strain gauge. Then metal foil. Then semiconductor strain gauge. Then bonded, unbonded. But generally in application point, semiconductor strain gauge the people used to go. And moreover, one more type is diffused metal strain gauge. Okay. So in this class we had a discussion on the strain gauge working principle and how it is going to measure strain as well as stress, and how we are deriving the expression for gauge factor. Then what are the metals we can use it, what is meant by positive strain and negative strain, and what are the different types of strain gauges are available. Thank you.